Okay, so these are the notes for 5.5. Let's see if the computer will catch up to me. That's weird. Okay, 5.5. There we go. In the first part, we're going to do some long division. So we're going to set up the division 8x squared plus 34x minus 1 with 4x minus 1 out here. What we're going to do to start is we're going to say, what would I multiply 4x by to get 8x squared? Well, 4 times 2 is 8, and x times x is x squared. Now that I have that value, I will multiply by 4x. 2x times 4x is 8x squared. 2x times negative 1 is negative 2x. To be able to move forward, I need to subtract. When I subtract, I will change all of the signs in the line that I'm working on. Now I have 8x squared minus 8x squared. Those will cancel. And I have 34x plus 2x. That's 36x. I bring down the extra piece, and I start all over. What would I multiply 4x by to get 36x? I'd multiply by a positive 9. So 9 times 4x excuse me, is 36x, and 9 times negative 1 is negative 9. But again, to continue on, I have to subtract. When I subtract, I'll change all of the signs. 36 minus 36 goes away, and I get 8. This here is my remainder, so I'll put plus 8 over what I was trying to divide by, which is 4x minus 1. And there's the answer for number 6. After that, we can get to synthetic division the rest of the way through, and so I always have to check to make sure I have all my exponents. I start with 3. That means I would need 2, 1, and 0. I have x cubed, but I don't have x squared. That means I'm going to have to use a 0 there. I have x to the first, and I have the one that has no x. So when I write my numbers down, I'll have 1, 0, negative 4, and 6. Over here, I always put the number that makes this 0. Well, that'd be a negative 3. And now I can start the process. If I bring the 1 straight down, to get back in I need to multiply by negative 3. So 1 times negative 3 is negative 3. I add 0 plus negative 3 is negative 3. Negative 3 times negative 3 is 9. Negative 4 plus 9 is 5. And I get negative 15. That produces a remainder of negative 9. So negative 9 as my remainder will be over x plus 3. And the rest of the problem, I'm trying to build off of this idea of this 3, 2, 1, 0, but I'm going backwards. So this would be like my 0, this would be my x to the first, this would be my x squared. So I'll have 1x squared minus 3x plus 5. And then of course I have this minus 9 over x plus 3. So I'm actually going to go in and move my negative sign out in front, so I know it's subtraction. And there's number 16. If I continue on 27, they give me one of the factors and say factor it the rest of the way. Well, the same idea, I'll use synthetic. It'd be 2, negative 15, 34, negative 21. If this is something that you struggle with, I'd encourage you to pause it and go through each step and make sure you understand why I'm doing it. But to make this 0, I would use a positive 1. The 2 comes straight down. 2 times 1 is 2. This would be negative 13. Negative 13. That would be 21. Negative 21. Oops, I made a mistake. So let's go back. See, I make mistakes too. Let's go back and calculate. Oh, I know what my mistake is. That was negative 13. That is 21. 1 times 21 is 21. That's 0. I need a 0 to show up once I start number 21 and onward. Okay, then this, I need to put the x's back in. Remember, this is my x to the 0, x to the 1, x to the 2. So I have 2x squared minus 13x plus 21, and I try to factor. Factors of 2x are 2x and x. My signs are the same and negative, so minus minus. And then I'm just looking for factors of 21 that add up, that with this will add up to 14, or to 13. So I'm just going to do 7 here and 3 here. This would be 7x, negative 7x, and that would be negative 6x. That's negative 13. So this is right. I just need to put in the original factor, which is x minus 1. And I'm done. Okay? So that's how we do 27. Again, it'll be synthetic, and then you'll try to factor that last piece. The last one we're going to look at is 31. Same idea, just small differences. I'd have 10 minus 81, 71, and 42. And instead of trying to change something, there's no x over here, so the number I'll use is just plain 7. That would have come out of something like x minus 7. And I say, oh, it's positive 7, and that's where I'll use this. I bring the 10 down, that makes 70. This is negative 11, that'd be negative 77. That'd be negative 6, negative 42, and 0. Then all I have to do is put this stuff back in. 10x squared minus 11x minus 6. I want to factor this down. I'm going to guess and check. Let's do 5x and 2x. I don't know my signs. Let's say we did 3 and 2. This would be 4x. That would be 15x. If the 15 is negative, I get negative 11. So I need that to be negative, that to be positive. But I want to know what actually I could plug into each of these to get 0. I know that up here I would plug in a positive 7 to get 0. So, 7 is one of these possible zeros. I want to know what else I could plug in. So I'm going to take 5x plus 2, set it equal to 0, and solve. 5x equals negative 2, so x equals negative 2 over 5. Negative 2 over 5. And then over here, if I did it again, I'd add 3 and divide by 2. That makes 3 halves. If you have any trouble with those, just set it equal to 0 like I did here and solve. In the back of the book, that 7 won't show up because it was given to you to start out. But it is important to realize that it and these other two numbers all give us 0 when we plug them into this equation. If I put 7 in here, I get 0, as evidenced right here. If I tried negative 2/5 and 3 halves, I'd get the exact same results. Good luck. Synthetic division over and over and over again. Hopefully that works for you.